Dear students, welcome to Learning Management System, Department of Collegiate and Technical Education. The subject is Analog Electronics, Unit number 4, Rectifiers, Filters and Regulators. The session number is 28. Myself, Mohan Kumar MR, Lecturer, HMS Polytechnic, Government Aided, Tumkur. The topics that are to be covered in this session are construction and working of center tapped full wave rectifier, efficiency, ripple factor, and PIV of full wave rectifier. Before going for today's session, let me have some quick recap over a previous session. In previous session, we had a discussion on rectifiers, definition, construction and working of half wave rectifier, efficiency, ripple factor, and PIV of half wave rectifier. We know that rectifiers means it is a device which is used to convert the AC input voltage to pulsating DC output voltage. The pulsating DC output voltage consists of some ripples, that is nothing but AC content, which is present in the output of the DC pulsating. So rectifiers actually it perform conversion of AC input voltage to pulsating DC output voltage. If you come for the construction part of rectifiers, it mainly consists of input AC voltage. The, this one is the transformer, this is the diode rectifier, and this one is the RL, that is nothing but load resistance. Here, the input source is AC. It is given to the primary winding of a transformer. The secondary winding is connected to the diode rectifier, and load resistance is connected in series with the diode rectifier. Here we are giving input supply voltage and we are getting the output as pulsating DC output voltage. Here I is the current, D means diode, RL means load resistor, T means transformer, and plus sign indicates the positive half cycle, minus sign indicates the negative half cycle. If you come for working part, during positive half cycle, this terminal becomes positive. This is terminal A and this is considered as terminal B. This terminal becomes positive and hence the current flows through the diode. The diode is said to be under forward biased condition and hence the current will flows through the diode and also to the load and gives the positive half pulses for the out in the output waveform. This is the positive half pulses which we obtain when the diode is said to be under forward biased condition. During negative half cycle means this half cycle, this terminal becomes negative and this terminal becomes positive. Hence, the diode is said to be under reverse biased condition. Hence, there is no current flows through this circuit. Hence, the diode is said to be under reverse biased condition. There is no current flows through the circuit through the load. Hence, the output which we are obtaining is not we are getting any output. Hence, this is the output line which we are getting as 0 and during negative half cycle. Again, the process, the cycle is repeating. The output which we are getting is same as during positive cycle. This is all about the construction and working of half wave rectifier, and the efficiency is defined as output power to the input power. Efficiency is defined as the output power to the input power, and the ripple factor is nothing but the output of the rectifier is of pulsating DC and it contains some AC content. It is ripple factor is defined as the RMS value of AC component, the RMS value of AC component to the average value of DC component, average value of DC component, and also PIV of half wave rectifier. PIV means that is the peak inverse voltage, which the peak voltage across the diode in the reverse direction. When the diode is said to be under reverse biased condition, the maximum voltage appears in the reverse direction. That is called peak inverse voltage. Okay, this is all about previous class. If you come for today's class, in today's class, we shall discuss on the construction of full wave rectifiers. In full wave rectifiers, if you come for a construction part, here this is the input AC signal which is having positive and negative pulses. The AC signal which consists of positive and negative pulses. First is positive half cycle and second one is negative half cycle. This is the input wave AC signal, and this input AC signal is given to the primary winding of transformer. This is the center tapped transformer. Here the center tapped transformer, which is this is the RL load, means load resistance, and here in this full wave rectifiers we are using two diodes, that is diode D1 and diode D2. These are the terminals, that is terminal A and terminal B. Here in this full wave rectifiers, we are giving an input AC signal and we are getting output full wave DC signal. Here, full wave DC signal. This rectifier circuit consists of two PN junction diodes, that is nothing but your diode D1 and D2. ಅಂದ್ರೆ ಈ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ನಮಗೆ ಎರಡು ಡಯೋಡ್ಸ್ ಇರುತ್ತೆ, ಒಂದು ಡಯೋಡ್ D1 ಮತ್ತೆ ಇನ್ನೊಂದು ಡಯೋಡ್ D2, and this is load resistance which is connected common to both the diodes. ಅಂದ್ರೆ ಇದು ಲೋಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್, ಇದು ಕಾಮನ್ ಆಗಿ ಡಯೋಡ್ D1 ಗೆ ಮತ್ತೆ D2 ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದೆ ವಿತ್ ಅಲಾಂಗ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಸೆಂಟರ್ ಟ್ಯಾಪ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್. ಇಲ್ಲಿ ಸೆಂಟರ್ ಟ್ಯಾಪ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಅಂದ್ರೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ಗೆ ಇಲ್ಲಿ ಸೆಂಟರ್ ಟ್ಯಾಪ್ ಮಾಡಿರ್ತಾರೆ. ಸೊ if you given this for AC voltage, when we applied the AC voltage to the input of the primary winding of transformer, this is of step down transformer. Here after getting the output from the transformer, this transformer is connected with a suitable turns ratio, that is N1 by N2. If you go for the operation of the circuit during positive half cycle of input voltage, the terminal A is positive and terminal B is negative. Here if you go for during positive half cycle, this terminal becomes positive and this terminal becomes negative. Hence the diode D1 is said to be under forward biased condition, the diode D2 is said to be under reverse biased condition. Hence the current flows through the load, that is IL, is which is equal to ID1. The current IL which is flows due to the current obtaining from the diode D1, that is ID1. During negative half cycle, in the negative half cycle, this terminal becomes positive negative and this terminal become positive, and hence the diode D1 is said to be under reverse biased condition, the diode D2 is said to be under forward biased condition. Hence this diode will gives the output current, that is IL, which is equal to ID2. The current is mainly flows during negative half cycle due to the conduction takes place by the diode D2. That is the diode is D2 is said to be under forward biased condition and the diode D1 is said to be under reverse biased condition in negative half cycle. Hence we are getting during positive half cycle, we are getting a positive pulse due to the conduction of diode D1, and during negative half cycle, the diode, due to the conduction of diode D2, we are getting one more positive half cycle. Hence, we are getting full wave full wave output in the full wave rectifier. Means we are getting full wave, constant full wave output in the full wave rectifier. This is the input waveform, and this is the output waveform. The output waveform which gives an output due to the conduction of both the diodes during two different half cycles. Here, consider a positive half cycle of input voltage in which the terminal A becomes positive and the terminal B becomes negative, and hence the diode is said to be under forward bias condition, and hence it conducts. ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ ಅಲ್ಲಿ ಡಯೋಡ್ ಡಿ1 ಕಂಡಕ್ಟ್ ಆಗುತ್ತೆ. ಡಯೋಡ್ ಡಿ1 ಕಂಡಕ್ಟ್ ಆಗುತ್ತೆ ಬಿಕಾಸ್ ಅದು ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಆಗಿರುತ್ತೆ. ಡಯೋಡ್ ಡಿ2 ರಿವರ್ಸ್ ಬಯಾಸ್ ಆಗಿರುತ್ತೆ, ಅದಕ್ಕೆ ಅದು ಕಂಡಕ್ಟ್ ಆಗಲ್ಲ. ಮತ್ತೆ the diode D1 which supplies the currents ID1, diode D1 ಲೋಡ್ಗೆ ಕರೆಂಟ್ ನ ಸಪ್ಲೈ ಮಾಡುತ್ತೆ. ಸೊ ಹೆನ್ಸ್ IL is equal to ID1. ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಹಾಫ್ ಸೈಕಲ್ ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಹಾಫ್ ಸೈಕಲ್ ಅಲ್ಲಿ AC ವೋಲ್ಟೇಜ್ ಪೊಲಾರಿಟಿ ರಿವರ್ಸ್ ಆಗುತ್ತೆ, ಅಂದ್ರೆ ಟರ್ಮಿನಲ್ಸ್ ಇಂಟರ್ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಟರ್ಮಿನಲ್ಸ್ ಇಂಟರ್ಚೇಂಜ್ ಆದಾಗ ಡಯೋಡ್ ಡಿ2 ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಆಗುತ್ತೆ, ಡಯೋಡ್ ಡಿ1 ರಿವರ್ಸ್ ಬಯಾಸ್ ಆಗುತ್ತೆ. ಡಯೋಡ್ ಡಿ2 ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಆಗಿರೋದ್ರಿಂದ ಅದು ಕಂಡಕ್ಟ್ ಆಗುತ್ತೆ. ಡಯೋಡ್ ಡಿ1 ರಿವರ್ಸ್ ಬಯಾಸ್ ಆಗಿರೋದ್ರಿಂದ ಡಯೋಡ್ ಡಿ1 ಕಂಡಕ್ಟ್ ಆಗಲ್ಲ. ಸೊ ಕರೆಂಟ್ ಲೋಡ್ಗೆ ಕರೆಂಟ್ ಹೋಗೋದು ಡ್ಯೂ ಟು ದ ಡಯೋಡ್ ಡಿ2 ವಿಚ್ ಸಪ್ಲೈಸ್ ದ ಕರೆಂಟ್ಸ್ ಟು ದ load D2. Hence, IL is equal to ID2. Hence, the load current flows in both half cycles. ಎರಡು ಹಾಫ್ ಸೈಕಲ್ಸ್ ಅಲ್ಲಿ ಲೋಡ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಹೆನ್ಸ್ ದ ವೋಲ್ಟೇಜ್ AC voltage in order to get the rectifier output across the load. In order to get an rectified output across, rectified means converted output across the load. Here, this is the diode during conducting, means this is during positive half cycle. Input is said to be under for positive half cycle. The diode starts conducting. Here the diode starts conducting and it is going to load, and we are getting a positive output here. And hence the load current flows both the half cycle, and hence AC voltage to get rectified output across the load. This process is repeated and it will give a continuous output in both the half cycle. Hence we are going to get two half cycle. In two half cycle we are going to get full wave output. The expression for maximum value of load current is given by Im is equal to ESM by Rf plus RL. Rf means forward resistance, RL means load resistance. The efficiency of rectifier is defined as the ratio of output DC to the input AC power of the rectifier. That is, efficiency is given by DC output power to the AC input power, that is equal to PDC divided by PAC. Therefore, the IDC is given by, which is equal to 2Im by pi. DC is equal DC power point, that is PDC is equal to I square DC into RL, 2Im square by pi into RL. AC input power, which is equal to the AC input power is given by PAC is equal to I square RMS into RF plus RL. For full wave rectifier, we have IRMS is equal to Im by root 2, PAC is equal to Im by root 2 whole square, which is equal to into RF plus RL. For full wave rectifier, the efficiency is given by efficiency is equal to PDC by PAC. If you substitute these values, 2Im by pi whole square into RL by Im by root 2 whole square into Rf plus RL, that will gives 8 by pi square into RL divided by RF plus RL, that is equal to 0.812 RL divided by RF plus RL, which is equal to 0.82812 divided by 1 plus RF by RL. If you substitute this answer, we're going to get maximum efficiency as 81.2%. In half wave rectifier, we are obtaining exactly half of this, that is nothing but 40.6%. Here in full wave rectifier, we are going to get maximum efficiency, that is 81.2%. The ripple factor of full wave rectifiers is defined as it is the ratio of AC component to the DC component. It is given by the AC component to the ratio of AC component to the RMS value of AC component to the average value of DC component. Here IRMS is equal to Im by root 2, IDC is equal to 2Im by pi for full wave rectifier. If you substitute these values, that is that is Im by root 2 divided by 2Im by pi minus of 1, which is equal to 0.48, it will gives the ripple factor of full wave rectifiers, that is 0.48. And if you come for peak inverse voltage, that is PIV rating of diode, the PIV is defined as the maximum possible voltage across the diode during when it is said to be under reverse bias condition. PIV means peak inverse voltage. It is defined as the maximum possible voltage across a diode during its reverse bias condition. Maximum possible voltage which appears across the diode during a reverse biased condition. PIV of D2 is equal to Vm plus Vm, which will gives 2 Vm. Hence PIV of D1 which is equal to 2 Vm. Hence PIV of full wave rectifier is 2 Vm. At the outcome of this session is, at the end of this session, the student will be able to understand the construction and working of full wave rectifier, efficiency, ripple factor, and PIV of full wave rectifier. Hope you all understood well. Let us go for MCQ questions, that is multiple choice questions. In full wave rectifier, the first question, in full wave rectifiers, the current in each diode flows for the options that are given is, first option is option A, whole cycle of the input signal. Option B is half cycle of input signal. Option C is more than half cycle of input signal. Option D is none of this. Let me check the answer for this. That is option B, half cycle of the input signal. We uses for a input for a full wave rectifier, the current in each diode flows only half cycle of the input signal, that is positive half cycle and negative half cycle. Only one half cycle uses in each diodes. The second question is, the maximum efficiency of full wave rectification is, the options that are given is option A 50%, option B 81.2%, option C 40.6%, option D 45.3%. We know that the for the full wave rectifier it is option number B, that is 81.2%. In half wave rectifier we are getting half of this, that is 40.6. In full wave rectifier, the maximum efficiency which we are getting is option B, 81.2%. And let me move on for third question, that is the ripple factor of a bridge rectifier is, Option A 0.482, option B 0.812, option C 1.11, and option D 1.21. We know that option A, that is 0.482. And the bridge rectifier is preferred to an ordinary two diode full wave rectifier because the option that are given are: option A, it needs much smaller transformer for the same output; option B, no center tap required; option C, less PIV rating of per diode; option D, all the above. If we check the answer, that is all the above. It needs much smaller transformer for the same output, no center tap is required, and less PIV rating per diode. The last question. The basic reason why a full wave rectifier has a twice the efficiency of half wave rectifier is the option that are given are: first option, that is A, it makes uses of transformer; option B, it ripple factor is much less; it utilizes the both half cycle of the input; option D, it output frequency is double the line frequency. Okay, let me check the answer for this question. The option is C. It utilizes the both the half cycle of input voltage. This is all about today's session. This is our team, and hope you all understood well. Thank you. Thank you all.